Hi and welcome to another video from AI Sciences. In this video, we are actually going to play a game using OpenCV. So most of you must be familiar with the Dinosaur game that you came across while your internet is down and the Google Chrome just prompts you with the game to play in that time. So that's Dinosaur game. We will try to play that game and control that dinosaur using the OpenCV and MediaPipe library. I'm your instructor Mohammad Ahmed from AI Sciences, and in this video we will try to control the dinosaur using the OpenCV and MediaPipe library, and we will try to play that game. And I'm not saying that we will do very good at that game, but I just want to give you the idea that how you can play with the games or control the game using the OpenCV. And also in this video we will use another Python library which I will introduce you after when we develop the basic structure on which we have to lay our foundation, and then I will introduce you with that library. So right now I just don't want to cluster you with extra information. If you are new to our channel, then just a brief introduction of the AI Sciences. That at the platform of AI Sciences, we are providing a lot of services regarding artificial intelligence and data science, including courses, including consultancies and on-demand software development, product development and whatnot. If you are interested in any of this, then do visit the links present in the description. So let's just begin. So if you go for Google Chrome and you just search for online dinosaur game, it will take you to this link like pocky.com, and if you open it, it will just simply provide you with the game. And if I now press spacebar, it will start the game and I can actually play around with this game. Okay, so this is the first thing that I want to actually show you, that this will be the game that we will try to play using the OpenCV and another Python library. Over here we are using again the MediaPipe library for detecting the hand gestures, hand motion, and detecting all these landmarks on the hand. And then based on that we will devise that whether we want to make the dinosaur jump or whether we want to send the signal to the dinosaur to jump, or we want it to crouch or just move down. So we will develop the basic idea, and the basic idea in my mind right now is that I will be considering this index finger 0.8, and I will just set a mark that if the index finger point is above that mark, then I want the code to send the jumping signal to the dinosaur, and if it's below that mark, then I want to send the crouch signal or going down signal to the dinosaur, and if it's on that mark, then I just don't want to send any signal. So that's the basic idea that right now in my mind. If you have anything at your end, if you have any improvisation, then please feel free to implement it on your own and do let us know as well. So I guess that's pretty much it from the theoretical and dry section. Now let's just move into the coding side. So first of all, we have to import the library CV2 and we have to import the library MediaPipe. If you don't have these libraries, then you will be getting something like underlined red over here. So what you have to do, you just have to click over it, go for Alt and Enter, and instead of optimize imports, it will ask you over here to import that library, and you can just import it straight away. Next is, so we have to go for capturing the video. So we can actually record a video previously and then we can apply all this thing on that, but that would be not nice, or that would be way too much dry. So we will be using webcam, and for capturing the webcam we have to go for cv2.video capture. So we are using this cv2 library and we are asking it to capture the video from our webcam by providing the 0. So 0 stands for the default webcam, which is the default webcam of my laptop in my case. Then let's just rearrange the size or rearrange the grid, the window of the camera. So we will go for cap.set and we will ask it to set the width, this thing of the over here, to be 1280. So 3 stands for that you want to set the width, and the other one if we go for 4, it is asking us for the height, so we can set it to 720, let's say. So it's not some random figures. Actually, I have already written this code, so I have the pre center points and I have the basic idea that where my coordinates will be and where my line will be, where my center mark will be. So I'm actually setting this according to that. So I would recommend you that if you are following along this video and you don't want to get in the hustle of doing all that stuff on your own, because it's a sort of a tricky mess that you have to do. So I would recommend you to go along with me and it will start making sense to you. Next is we have to develop the object for getting the hand landmarks. So we will go for MP hands and we set it to mp.solutions.hands. Right now, again, if anything is not making sense to you, then don't worry. Eventually, when I will start using this stuff, then this thing will start making sense to you. So if you are not understanding anything at the moment, then don't panic, just get along. Eventually, everything will make sense to you. Then we want to get the hands object. We need to get this MP hands object, and from that we have to get the hands. Next is we have to get the draw utilities. So draw means that if we just go for moving our hand, the computer can detect it, the OpenCV can detect it, and we can do anything we want to do. But just to get a better visualization that what computer is seeing, it's usually a best practice to draw on the hand and observe that what computer is seeing, and you can actually portray further, you can take further decisions based on that. So we will go for MP draw and we will set the solutions and we will go for drawing utils. That's it. Again, in this, I'm using two main colors. The first one will be the green color. So let's just create a tuple for that. You can choose any color, totally depends on your taste, totally depends on your choice. And I'm going to use a white color. So for the white, it's 255 all over. Next thing, so up till now we have imported the required libraries, and we have actually included the excluded the one library that we want to send the signals to the Dinosaur game, and we will just introduce it when we develop the basic foundation and we came across that point where it is necessary to use it. So right now I'm just using the basic foundation, basic steps to create that framework. So we have the CV2 imported, we are referring to the media pipe library, then we are capturing from the video webcam, and we have devised the way for extracting the hand landmarks and drawing that hand landmarks on the hand. Next is we have to iterate on it. Let's say we go for while true, because we just need to run it forever. Now if we go for this capture that we are asking it to recapture from the webcam, we will refer to this cap and we will go for .read. Now it will just simply read the picture or take a picture from the webcam and provide inside this for loop. Then again it will take the picture, or more precisely, it will take each frame out of the video and process it inside this while loop. So we will be getting a tuple of success and the image. So it will return us here true if it can successfully read the image from the webcam. Otherwise it will return us with the false, and if you want you can check it that is this point making any issue for you. You can just print this success, and if you get the true, so that means that the webcam is getting the value. The webcam is actually sending you the value in the code, and there is something there is some other thing wrong inside your code. So let me just flip it as well, and the reason why I'm flipping it, because otherwise it will be my left to my right and my right to my left, and it's quite irritating. So we will go for flipping it, and we want to flip the image on the axis 1, and then if we go for converting that image, because usually whenever we want to work on the OpenCV and we want to extract the land hand marks using the media pipe library, we always have to convert the image to the from BGR blue green red to the RGB image. So we go for getting this image, and we will ask it to go for CV2 dot color BGR to RGB. Now it is okay for us to go for hands and set it equals to hands dot process. image RGB. Okay, I forgot to declare that variable. So image RGB over here. So let's just run this, and then we will move further. So at this point, we are just reading the frame from the webcam. Then we are flipping that frame to the proper orientation, and then we are extracting we are converting the image from BGR to RGB, and then we are extracting all the hand landmarks and all the information that is available inside the hand. The media pipe library, this one will extract all this information that we can see over here, all these landmarks. Now if we want to display that, or if we want to run it, we just need to go for here, go for cv2.imshow. Now let's just name this window to be Dino game. You can name it anything. And the image that we want to display over here is this image. And then we have to go for cv2.wait key, and let's just put 1 here. Now if I just simply run it, you will notice that nothing will happen. We will only be getting the basic webcam working, and we can wave to it. So if we go for this terminal, and here we go for python main.py, it will just start the webcam. And okay, so here we are using the hands, and here we are using the hands as well. So we have to make it results, because for the first iteration it was working fine, and as we have overwritten the value of hands at this point, so it was again for the next iteration this hands was something else. So we have to go for make it results. Now if we clear the screen and give it a go one more time, so we are getting the camera, and we are getting this UI, this window. Next thing is we have to just display a line and display the basic center point. And after going that, we will work with the hand landmarks. If you are not getting these along with this hand landmark thing, then you can comment this out for the moment. And after when we will start using it, then we will again introduce it back here. So we will go for CV2, create a line. We want to create a line on the image, and we want to start it from the point 640 to 0, which is the center point of the screen, this one. And we want to go it to all the way to the bottom. So we will go for 640 and 720. The color I want it to be is white. You can go for any other color. And for the thickness, I just want the line to be of thickness 10. Again, this is not some random values. I have already pre-configured these values or pre-inferred these values. So I'm just using those values over here. Next, to draw the center point, let's just go for a rectangle. So we will go for CV2. We want to draw a rectangle on this image. The starting point would be 600 and 260. And the ending point would be, we have to give this point and this ending point, and it will automatically complete the triangle for us, or rectangle for us. Then for the ending point, we have to go for, let's say, 680 and 460. The color I want it to be green, and I want it to be filled. So now if I just run it, hopefully we will be getting a line, and we will be getting a rectangle inside in the center of that line. Perfect. Now the basic idea is we will infer the hand landmarks, and then we will check that if this index finger is in this region, we will consider it as that we don't want to send any signal. And if it is above that, we will send the signal of jumping, and if it is below that, we will send the signal of crouching. So let's just go for it. So we have to go for this one and the results, and we will go for results dot multi underscore hand underscore landmarks. Now what this thing is doing, this statement is basically taking this image, and it is extracting all the, it is checking for all the hands available inside that image, and then it is when we are referring to this point, this variable, it is basically providing us with all the landmarks available on the hands. So we have to go for the, let's just save it in multi landmarks variable, and then we can just simply check that if we are getting any multi landmarks variable. So that means if there is any hand inside the image, this thing will detect that detect that hand inside the image, and this thing will provide the landmarks or coordinates for that hand to this variable. And if there is no image, it will not provide anything, and by default it will be set to none. So here we have to check that if we are getting any image, any hand inside the image, then we want to proceed further. So we will go for extracting the hand points. In case we have some hands, in case we have any hand, let's just make it simple. If we have any hand inside the image, then we want to capture the hand points, which is these points. We want to capture all these coordinates. So we will go for this one, and we will go for hand landmarks in multi landmarks. So it is iterating on each hand. For the first hand, it will provide us all the coordinates, and for the second hand, it will provide us with all the coordinates. We are working with the single hand, so we will get only one iteration of this. So we will go for MP draw, and we will just simply ask it to draw landmarks on the image, and we need to draw the landmarks on these hand LMS that we have just extracted over here, and we need it to be connected. So we will go for MP hands dot hand connections, right? So now if we just run that, you will notice that we can get the hand, and actually it's detecting the hand, and it is printing it is printing all those landmarks inside this hand. Perfect. Next thing is we have to extract all the coordinates of these hand points. So right now we are getting all these points, but we need to save all these coordinates to something, to some list, so that we can access this 8 and we can apply the further logic to it. So we will just iterate on it by saying the LM in, let me just write it first and then I will explain it to you. In rate the hand LMS dot landmark. Now what this statement is doing, this statement is basically providing us with all these 20 landmarks over here. So all these 20 landmarks, and we are getting it for each iteration. For first iteration we are getting this, then for the next iteration we are getting 1, 2, 3, 4, so on and so forth. Now to save it, we will just go for hand points and we will append it inside this. So we can just simply go for appending the LM over here. But the issue with this is that this landmarks over here is basically not the actual coordinates that we are looking for. It's something more related to pixels. So to convert those to the coordinates, we have to go for H, W, and C and image.shape. Now this statement will provide us with the image height, image width, and image current color scheme, whether it's RGB, BGR, black and gray, whatever it is. Then to convert the X coordinate to move from pixel to coordinates, we have to go for CX, and we will just simply convert it to integer for lm.x multiplied by width. So we are taking that coordinate, this one that we are iterating on. So let's say if we are going for this 0, it is taking this coordinate, multiplying it with the width, and we are getting it as a proper coordinate that we are interested in. Same for the CY as well, and here let's just move this here with the Y and multiply it with the height. So this statement CX will get this value, and this statement over here CY will get this value. And then we have to just append it inside this by CX and CY. That's it. So now if we just run it, and let me just print it as well. Okay, let's just iterate on it and print it. So after getting all the hand points, we will go for point in hand points. We need to just print the point. So let me just clear this, give it a go. So here, see, it is now actually detecting all the hand points, all the hand landmarks, and it is just printing those coordinates over here. And as soon as I just move my hand away, it stopped detecting the hands. And the reason why we are getting this hand over here is not because I have a ghost in my house. It's just because due to some bad lighting and due to some camera poor quality, we are getting some extra glitches. So don't really worry about that. Next thing is that we have detected the hand landmarks, we have detected the hand points, and now we have to go for this point 8, the index finger. So for extracting that, we have to go for here. And let me just print it for you first, and then I will show you that how this thing is happening. So we will go for hand points, and inside the hand points we will go for the point 8, which is this index finger point. So if I give it a go again, okay, so just observe that now if my hand is stiff, this is the x coordinate of the hand, which is around 800 and something, and this is the y. Now if I just move it over here, you will notice that this thing is same, but this thing is decreasing, which is the x value. And if I move all the way to here, the x is increasing and the y remains the same. Same is happening for the y. If I move it down, it will increase the value of the y, and if I move it up, sorry, it will increase it over here and it will decrease it over here when I move it up. So that's how these x and y coordinates are working with the index finger. So I hope that this thing is pretty much clear for you at this point. Next thing is we have to detect that if our index finger point is above the green mark or is it below it. So we will have to just simply use the simple maths. We are getting the index finger, then we are extracting its y coordinate, the later one that I showed you. We have to check that if it is less than 260. So if, let me just comment this. So this mark over here is basically equal to 260, and I'm checking that if my hand is basically above this, then I'm considering it as up. And this mark over here, the bottom of the triangle is basically at 460 because we drew it, so we have the idea. And we will be checking that if it is below this, then we will consider it that our hand is below that landmark. So we are checking it over here that if it is below 260, so that means it is above the particular rectangle. And in that case, we have to just print the up statement for now. And else we have to check the hand endpoints, go for 8, go for y coordinate, and check that if it is greater than 460, then it's basically down. We have to send the down signal. And else it's center. That's it. So if we run it, and then after that we will see that how we can introduce the new library that will connect us with the game. So this is the screen, and here, so currently you can see that it's in center, and if I move it up, it's up, it's again in center. If I move it down, it's down. Perfect. Now next thing is we have to just simply use a library named as PyAutoGUI. So let me just import this first, and for you, if you don't have it, you just need to go for, again, hover over it and go for Alt Enter, and it will ask you to just simply install it. Now if we are at the up point, what we have to do is we have to just go for PyAutoGUI.key, down that we wanted to press the key of space, and then we wanted to key up or just simply remove the key for space. Now as soon as I move my hand above, it's just like that if I press the spacebar key, it will replicate the same thing over here. So it's just like that I am pressing the spacebar key. Same will happen over here, and this statement is representing that I am leaving the spacebar key, or I am putting my finger up from the spacebar key. Same if we are in the down statement, then we need to press the down key, and then we need to open the down key, or just move our finger up from the down key. So this is the basic idea. Now if we go for the game, and here's our game, let's just squeeze it over here and refresh it. Okay, here we have this. Let's just clear the screen, and if we run it, here we are getting it. And again, I'm not saying that I'm very good at this game and I can beat anyone's record. So this is just for the learning purpose, that how you can control the game using this one. And now if I go for this one, and if I just click on this, okay, let me just refresh it. And yeah, so as soon as, okay, it's basically detecting some land hand marks. So if I go for here, and it's center, and if I go up, it is moving up. Oops. Okay, let's just give it a go again. So the basic idea was not to play the game. So if I go for down, it's going for down, and if I go for up, it is allowing us to play the game. So I'm actually not, the basic idea was not to play the game, was just to give you the idea that how you can control the game using the OpenCV and using the Python library. Still, if you want to get along with that, you want to play with that, I would highly recommend you to play and develop your skill set, and just show it to your friends as well, because it's quite cool. Also, it's not only limited to this stuff that you can only play with this game. You can go for any other game available over here, and you can just tweak the codes, because we have learned pretty much very healthy stuff for the OpenCV. You can tweak the things, and you can play along any game using your hand gestures, using your movement of the fingers, position of the fingers, whatsoever. So this is pretty much it from this video. Again, this video was not that how good I play this game, that this video was just to give you the idea that how you can control the player using the Python code. Again, if you have any questions, any concerns, then please do let us know in the comment section, and we will try to get back to you on that as soon as possible. Also, please do hit the bell icon and do subscribe to our channel AI Sciences, so you get the notifications of our upcoming videos. This is pretty much it from my side. I will see you in the next video.